There is a question that has resonated through the corridors of human history, a question that seems to have shaken every civilization, transcending the boundaries of all languages and the dogmas of all religions, echoing in the cathedral of the human mind for thousands upon thousands of years. It is a question that feels intimate, almost personal, and yet it addresses the entirety of existence. What was there before the Big Bang? It seems, on the surface, to be such a simple inquiry. It is the sort of question a child might ask, gazing up into the velvet darkness of a winter night, and yet it stands as one of the final, most formidable frontiers of our knowledge. It is the place where thought, language, and even the very laws of physics upon which our technological civilization relies begin to dissolve like mist burning off under the morning sun. For in asking about before, we unconsciously assume that time is a constant, a river that has always flowed, that there was some steady progression of moments that passed prior to the birth of the universe. We imagine a clock ticking in the void, waiting for the main event to begin. But this is where our intuition, that evolutionary tool sharpened on the savannas of Africa to help us hunt and gather, betrays us. If we follow the threads of modern cosmology, if we listen to the story told by the equations of Albert Einstein and the observations of our most powerful telescopes, we are led to a conclusion that is profoundly difficult to wrap our minds around. If time itself was born in that very moment of the Big Bang, then the word before loses its anchor. It becomes a ghost of a concept, drifting without meaning. According to our current understanding of physics, particularly the general theory of relativity, when we say the universe began with the Big Bang, we do not merely mean that an event occurred in a pre-existing empty room. We mean that space and time, the two foundational concepts that define every place and every moment we have ever experienced, did not exist before it. Strange as it sounds, almost alien to our daily experience, that is the direct conclusion when Einstein's general theory of relativity is pushed to its absolute limit. At that boundary, the equations that describe the graceful orbits of the planets, the bending of starlight around the sun, and the terrifying gravity of black holes, these equations simply explode. They cease to function. All quantities become infinite. Space-time curvature grows without bound, and so does matter density. Physics calls this a singularity. It is a word that sounds technical, perhaps a bit dry, but behind that abstract name lies a stark and humbling truth. The very laws that have described the universe for more than a century, the laws that allow us to fly spacecraft to the edge of the solar system, no longer predict anything. They fall silent. They no longer tell us what happens next, or indeed what happened previously. And precisely there, in that silence, a new question opens up, one that bridges the gap between science and philosophy. If the laws of physics collapse at the beginning, does that mean the universe truly had a first moment? Or are we simply missing a deeper layer of understanding, a substrate of reality that no theory has yet reached? Perhaps the Big Bang was not an absolute beginning, but merely the first expression we can comprehend of something far older, far deeper, and infinitely more majestic. If we remain faithful to what relativity asserts, then time is not a clock ticking independently of the universe. It does not flow somewhere outside, like the steady motion of a conductor's baton sweeping through nothingness. Time is part of the very fabric of the cosmos, woven together with space, energy, and matter into a unified tapestry. This means that when we say the universe began, we're also saying time began. The question, before the Big Bang, therefore loses all meaning, much like asking, what is north of the North Pole? Imagine standing at the North Pole. You can sense the cold, you can perceive the horizon, but if you try to take a step further north, you cannot. There is no cliff, no abyss, no edge to cross. The geometry of the Earth simply curves back upon itself. There, the concept of north simply does not exist in the way we usually understand it. Yet, this is something profoundly difficult for the human mind to accept. We are creatures of narrative. All our experiences are woven upon the loom of time, a chain of consecutive events where causes lead to effects. From the beating of a heart to the growth of a child, to the turning of planets around their stars, all follow that order. Thus, when we are told that before the Big Bang did not exist, our instincts rebel. We try to fill that void with something familiar. We imagine a black emptiness, a waiting room for creation. However, in the realm of physics, the feeling of familiarity is not the measure of truth. The universe is under no obligation to behave according to what humans find reasonable or comfortable. And when we delve deeper into mathematics, the equations all point in the same direction. The Big Bang was not only the beginning of matter and energy, but also the beginning of time itself. If there was no before, the universe needs no cause to exist in the traditional sense. There was no empty space in which a cause could act. Everything simply is, existing with time, emerging simultaneously with the very conditions that make existence possible. It is an idea that unsettles many, for it seems to remove the need for an origin, for a why behind all this. Yet perhaps that discomfort arises only from the limits of intuition, and intuition evolved to grasp chains of events. A lion chasing a gazelle, a rock falling from a cliff. Not the birth of space-time itself. When scientists look deeper into cosmological models, they realize that the Big Bang might not be the beginning of everything as once thought. It could have been merely a transition phase, a point where space and time changed state rather than began. Absolutely. Perhaps before it, there existed another universe, collapsing and compressing its energy in preparation for the next rebound, what we now call the Big Bounce. Or perhaps time itself is cyclical, an endless loop of expansion and contraction, where each cosmic era is but a single breath in the infinite ocean of existence. Yet, regardless of the model, one thing remains constant. All our familiar concepts, cause and effect, beginning and end, dissolve at the boundary of time. There, language loses its power, and causal logic has nowhere to stand. We stand at the edge of knowledge, where the silence of physics meets the curiosity of humankind. The wonder is that even in that helplessness there is beauty. For if space and time are not a fixed stage but part of the play itself, then the universe is writing its own script, not coming from anywhere, not heading anywhere, simply being. And in realizing that, we no longer need to ask what was before the Big Bang. We only need to listen to the meaning of this very moment, where time continues to give birth to each instant, and existence keeps asking itself why it exists at all. The question, what was before the Big Bang, therefore is not a mistake but a mark of awareness. It proves that even though the human intellect cannot yet see beyond time, it is still brave enough to ask where time itself began. And in that instant where knowledge meets its own limitation, the universe becomes closer than ever, as if it were waiting for us to understand that sometimes there is no before or after, only the present where everything begins and has never truly ended. At the far edge of understanding, where numbers lose their meaning and every model collapses, there is a boundary called the singularity. It is not merely an abstract mathematical concept, but a gateway to the place where physics, the very thing that has described everything from planetary orbits to quantum particles, falls completely powerless. All that was once taken as law dissolves. There is no time, no space, only a condition for which human language was never designed. When Einstein's equations are pushed to their extremes, the curvature of space-time becomes infinite. Matter density rises without bound, and energy concentrates into a point of no size. Imagine, if you can, the entire universe, with its hundreds of billions of galaxies, its quadrillions of stars, its nebulae, its black holes, its planets, and its civilizations, once compressed into an entity smaller than a grain of sand, smaller than an atom, smaller than a proton. There, every notion of before and after, inside and outside, vanishes because there is no framework left in which such notions can exist. The singularity is not a place one can picture with the eye. It is a frontier where all current theories cease to be valid. It is like the cliff edge of an old map where the ancients would write, "Here be dragons. Beyond this point lies the realm of the unknowable." And ironically, precisely where physics stops working, humanity's deepest question begins to speak. What happens there? Does anything exist before space-time is born? Or is this the one point where before and after are nothing but Mayas in the human mind? From what we know, today's universe is expanding. Galaxies recede from one another, their light stretched into red streaks, the famous redshift that Edwin Hubble first observed. If we imaginatively reverse this process, winding the cosmic film backward, we see everything contracting. Density rising, temperature climbing, the vast voids between galaxies shrinking, until all is squeezed into a single point, the primordial singularity. At that point, time has no flow, space has no direction, physics has no law. It is the ultimate limit to which the equations can lead, and beyond it, we step into the realm of the unknown. The astonishing thing is that this shattering is not the period at the end of knowledge, but an invitation to take one step further. When a theory collapses, it does not end inquiry. It opens a new depth of understanding. The singularity does not say the universe stops. It says the way we look at the universe must change. Perhaps Einstein's classical physics is no longer sufficient to describe reality at the smallest scales where energy and space-time mix in a quantum choreography not yet deciphered. Under such extreme conditions, every notion of order dissolves. There is no before from which to pose a question, no after in which to await a result. There remains only a reality beyond causality, where every cause and effect happens simultaneously, or perhaps nothing happens at all. This is where physics turns into philosophy, where we stop looking for the how and begin seeking the meaning. When we observe the universe billions of years after that initial point, everything seems to run flawlessly. The law of gravity keeps planets moving around stars. The nuclear forces balance life and destruction within the heart of atoms. Yet all of that order began in an absolute chaos where order had never existed. From the impossible, the possible arose. From chaos, structure emerged. From the silence of space-time, the universe's first beat resounded. This compels us to ask a new question. If physics cannot describe the singularity, does that mean there is something beyond physics? Or is it simply that our tools are still crude, like the first line scratched in sand trying to sketch the sky? Some scientists argue that the collapse itself is evidence that the universe conceals a deeper layer of reality, where quantum mechanics and gravity are no longer separate. There, time may not be a flow, but a fabric woven from countless quantum fluctuations, a network of probabilities rather than a chain of causes. Whatever it may be, the singularity remains the wall that bounds our cognition. Every theory we have, however sophisticated, stops at that door. It is like the horizon line of knowledge. We can approach, measure, infer, but we cannot cross. All data, all formulas on reaching it dissolve into infinities. For this reason, the singularity is not only a physical phenomenon, but also a symbol of human incompleteness, a mark that we live in a universe whose very nature is deeper than our capacity to apprehend it. What makes this frontier beautiful is that it rekindles the oldest feeling in the history of science, wonder. From Galileo first seeing Jupiter's moons through a telescope, to Einstein writing equations that describe curved space, every step forward began with a moment of astonishment before the incomprehensible. And now, at the singularity, we again face another veil of the cosmos where understanding melts away, and our sense of human smallness becomes sacred. Physics may have stopped there, but the questions have not. For behind the collapse of laws lies a deeper order waiting to be seen. Perhaps the universe did not begin from nothing, but from a state without definition, where the principles of existence were only beginning to form, and perhaps from that very impossibility everything began. When we understand that the singularity is not a black hole of knowledge, but a spring of curiosity, we begin to perceive the subtlest thing. The universe is not silent. It is still speaking. We simply lack the language to understand. And perhaps one day, when quantum theory and gravity find a common tongue, when we rewrite equations that no longer explode at time zero, we will not only describe the universe's beginning, but also touch the essence of existence itself. Until then, the singularity remains a living symbol where knowledge bows before what exceeds it, where we realize that the greatest understanding lies not in answers, but in daring to walk to the limits of what can be understood. And in that silence where physics stops working, the universe goes on breathing, goes on hiding. As if waiting for humanity to grow, mature enough to grasp that some things need no solution, for not knowing is sometimes the deepest form of knowing. Everything began not within a place, but as the birth of the very place itself, not within a moment, but as the moment creating itself. When we speak of the Big Bang, the familiar image that arises in our minds is that of an explosion bursting from a point somewhere in infinite space. We imagine shrapnel flying out into a dark, pre-existing void. But in truth, there was no outside into which it could explode. For before the Big Bang, space did not yet exist. What burst forth was not matter expanding into a pre-existing void, but the void itself being born along with matter, unfolding from the primordial energy of the universe. It is like inflating a balloon, not air exploding into a room, but the surface of the balloon itself expanding, creating new space within it. Time, too, follows the same principle. It was not a river already flowing from somewhere that was swept along by the Big Bang. Time was born in the very instant the universe came into being, and from that moment onward, everything, light, energy, matter, and life itself, has flowed along the current it created. When physics says that time began at t equals 0, it is not a metaphor but an almost metaphysical precision. For at that point the concept of before does not exist, and the concept of after only begins to hold meaning once the universe starts to expand. According to general relativity, time and space are not two separate entities. They are two faces of a single structure, space-time, woven together by energy and matter. Every planet, every star, every particle of light bends this fabric, causing it to curve, stretch, and twist in its own way. This means that time does not flow uniformly. Like the ticking of a clock on a wall, it bends under the very presence of matter. Where there is mass, time slows down. As space expands, time stretches along with it. From this, a profound truth emerges. Space and time cannot exist independently. They were born together, bound together, dissolved into one another, and together they form the stage of all existence. Though this may sound abstract, it is in fact the foundation of the reality we live in. Each second that passes on Earth is not identical to a second in the depths of interstellar space. A photon leaving the halo of an ancient star has travelled not only through space, but through the stretched flow of time. And when it finally touches the human eye, it carries the memory of billions of years. That is why when we gaze up at the night sky, we are not seeing the present but the past, the very epochs when space and time were still shaping themselves. The wonder of this idea lies not only in how it transforms our understanding of the universe, but also in how it reshapes our understanding of ourselves. If time did not exist before the Big Bang, it means the universe did not appear within time. Time appeared together with the universe. Therefore, to ask why there was a beginning or who created it becomes a question that falls into a void because at the most fundamental level, beginnings and endings are products of human perception within an unfolding universe. The universe needs no cause to begin, for the concept of cause exists only within the flow of time, and time was born along with it. This realization transforms the very definition of reality. In modern cosmological models, the universe is not an object sitting in fixed space. It is the expansion of space itself carrying time, energy, and existence along. Each passing moment is not simply a second sliding down a pre-existing timeline, but a continuous act of creation by the universe itself, as it keeps weaving new threads into the fabric of being. As physicists look backward along the timeline, they find that the universe was once so hot that all structures melted away, where light, matter, and energy became one. And the farther back they go, the more space contracts and time distorts, until the two are no longer distinct. Only a unified field remains, a pure existence without inside or outside, before or after. It was in that very instant that space-time was born, unfolding the universe as we know it today. The simultaneous birth of space and time also shakes the foundations of classical philosophy. Where philosophy once asked, "Where is the world in time?" modern cosmology answers, time itself is part of the world. There is no such thing as outside the universe from which to look in, because every notion of outside requires space, and space begins only here. This means the universe does not exist within anything. It is everything that exists, and within that simplicity lies infinite depth. The universe was not born in time, but with time. Seen from this perspective, the beauty of relativity becomes clear. It is not just a set of equations describing orbits. It is the first symphony of creation, where space and time merge into a single melody. Every vibration of energy, every ray of light travelling through the void is a note played upon the grand fabric of space-time. And within that symphony, our existence is but a brief phrase, sounding for a few fleeting moments before blending back into the whole. Yet in that brevity, humanity possesses the ability to perceive the rhythm of the entire cosmos, to look back across billions of years and ask about the very moment when time itself began. That question is not mere curiosity. It is consciousness recognizing that it flows within space-time and is itself a product of it. If space and time were born together, then perhaps consciousness, the universe's capacity for self-awareness, is also part of that process. For only when time began to flow did the sense of before and after emerge. And from that flow, through countless pulses of expansion, a small species on a blue planet began to look back toward its own origin, striving to understand what created it, even as it continues to be created with every passing second alongside the ever-expanding universe. The story of space and time is not merely a scientific theory, but a declaration of the unity of all existence. There is no longer a separation between background and content, between the flow and the one who flows, between the universe and the observer. All are one. And in realizing that, we understand that each moment passing is not merely a fragment of life, but the continuation of the primordial instant where space and time are still being born together. Not in some distant past, but right now in every breath of the cosmos. In the first instant after the Big Bang, everything we call the universe had yet to take shape. There were no galaxies, no light, and not even particles that could be called matter. There was only a seething sea of energy chaotically fluctuating, where the laws we are familiar with had not yet come into being. At that scale, Einstein's laws no longer apply. Space is so curved that every classical equation shatters, and it is there that quantum mechanics, the language of the very small, begins to speak. If relativity describes how planets move through space, quantum mechanics describes how the smallest constituents of reality exist in indeterminacy. The quantum world is not like the world our senses perceive. There, particle and wave are one, existing in a state we call probability. Each particle can be in many places at once, follow many different paths, and only when observed does it choose a specific reality. When we carry that concept back to the universe's beginning, an extraordinary story appears. Perhaps the universe did not explode from an absolute point, but began as a quantum fluctuation within nothingness itself. From this viewpoint, nothingness is no longer empty. It is a background energy field in which tiny fluctuations occur incessantly. They are vibrations of space-time itself, unseen yet real. From time to time, within that ocean of fluctuations, a large enough disturbance arises, stirring up a region of concentrated energy. That region swells, and if the conditions are right, it can become a universe. This is the bold idea modern physics calls quantum inflation. According to it, our universe did not explode from a single point, but is a bubble that swelled in an infinite ocean of energy. As the swelling began, the energy of this quantum field transformed into matter, producing the first elementary particles, protons, neutrons, electrons, the foundations of all later atoms. It was the tiny fluctuations in that energy that left imprints, creating denser regions where, after billions of years, galaxies, stars, and planets would form. In other words, every vast structure in the universe today traces back to quantum ripples smaller than an atom. In that first instant, quantum randomness sowed the very first seeds of order. The paradox is that the universe was born from a state our language cannot name. It is neither wholly something nor entirely nothing. At the Planck scale, smaller than anything, experiments can measure the boundary between existence and non-existence grows faint. A particle can appear and then vanish almost immediately. And in that endless chain of fluctuations, perhaps one such appearance was strong enough not to fade, and that was the universe. No one knows what determines that moment, but we do know that quantum mechanics allowed the possible to arise from the void. When the universe was smaller than an atom, it followed the rules of probability. There were no fixed orbits, no linear time. Everything existed within a cloud of possibilities where every reality could happen. In that picture, the beginning is not a single event, but a phase transition. When the quantum universe became a classical one, when time began to flow, when cause and effect began to make sense, that moment, the instant when the quantum condensed into reality, was the very first moment of existence. The birth of the universe from quantum fluctuations is not merely a mathematical hypothesis. It leaves traces in the very canvas of today's sky. When space telescopes observe the cosmic microwave background, the remnant of the Big Bang, they reveal spots of slightly different brightness, signatures of primordial quantum fluctuations stretched out by expansion. Those minute differences, only a few parts in 100,000, determined where would become galaxies and where would remain void. Every star, every planet, every intelligent being, including us, originates from those random fluctuations. We exist because a vibration in the vacuum happened in a particular way. But that also confronts us with a larger question. If such fluctuations can produce this universe, how many other universes have been born where different probabilities yielded different realities? Physics calls this the multiverse idea, in which each quantum possibility is not lost, but becomes a universe of its own. That is, in an infinite ocean of energy, countless other universes are budding, each carrying its own physical constants, its own laws, even entirely different notions of time. If so, our universe is not unique, but merely a quantum speck in an endless wave of creation. Though this remains beyond verification, it hints at a profound truth. The universe needs no external initial condition to exist, because the quantum fluctuations of nothingness are already laden with possibility. What we call nothing is not empty at all, but a hidden lattice of energy, always in motion, always ready to swell into something, as if the universe bears within itself the instinct to self-realize a creative cycle that needs no external hand. With this understanding, the image of the Big Bang grows more poetic than ever. It is no longer a birth cry explosion, but the awakening of possibility, a moment when probability turned into reality. Every burning star, every drifting photon is a remnant of that moment, and when we look up at the night sky, we are seeing the very first quantum seeds, the imprint of the unimaginable present in every ray of light crossing space. The most wondrous of all is that this quantum randomness created not only the universe, but also the very consciousness striving to comprehend it. From an indeterminate fluctuation, the universe evolved into particles, then atoms, then stars, and at last into beings capable of awareness. Which is to say, from randomness sprang the capacity to question randomness itself. Humanity, in a sense, is the universe's answer to the question it once posed when it existed as pure energy. Hearing this, one may sense that quantum theory is not only a scientific tool, but also a philosophy of genesis. It says that nothing needs a reason to begin. The very possibility of existing is sufficient for existence to occur. And in that light, the universe's first seed was not merely an energy fluctuation. It was the moment the universe knew it, could exist, and chose to become real. The universe, as we often imagine it, resembles a one-way journey beginning with the Big Bang, expanding, cooling, and finally ending in cold desolation. But perhaps that is only a small slice of a grander symphony, where the universe does not die but breathes. Each cycle of expansion and contraction is a breath of existence, an endless rhythm of creation and destruction, where the death of one universe becomes the whispered beginning of the next. In this vision, the Big Bang is no longer an absolute beginning but a heartbeat within the infinite heart of the cosmos. When physicists look back into the past, they see a universe in expansion. every galaxy drifting away, its light stretched into red bands. If this trend continues, the universe will thin, cool, and eventually fade into the darkness of heat death. But perhaps this process does not go on forever. If dark energy, the mysterious force driving expansion, changes over time, or if gravity grows stronger in the distant future, expansion could slow, stop, and then reverse. The universe would contract, drawing everything back together, every star, every galaxy, every atom collapsing into a brilliant searing point. And when that point reaches its limit, a new rebound, the Big Bounce, might occur. One cycle ends, another begins. This is the idea of the cyclic universe. A profoundly evocative model pursued by modern physicists such as Roger Penrose, Paul Steinhardt, and Neil Turok. In this model, time has neither beginning nor end. The universe is not born from nothing, but is reborn from its own ashes like a phoenix rising from fire. Each cycle is an epoch lasting trillions upon trillions of years in which all that is familiar, the physical laws, the fundamental constants, may remain the same or shift slightly, creating child universes, each a variation of the same eternal melody. What makes this model so alluring is its balance between destruction and creation. Each time the universe contracts, energy, matter, and even entropy, the measure of disorder, are restructured. What was lost in one cycle can be refined and rekindled in the next. Some models suggest that expansion can dilute entropy, allowing each rebirth of the universe to begin with renewed order, as fresh and pristine as the first. In that rhythm there is no absolute death, only the continual transformation of being. If that is true, then our very concept of time must be rewritten. Time is no longer a straight line, but an infinite spiral where beginning and end are merely 2 points on the same motion. Everything that has ever existed might exist again, yet never quite the same. Like a melody replayed with new notes, but carrying the same soul. And when we think of it this way, we begin to see that the universe is not a mechanical construct, but a living being that breathes, a vast organism within which we live. Perhaps it is this idea that the universe may be cyclic that evokes both comfort and awe. Comfort because it erases the fear of an ending, or because it suggests that everything may have happened countless times before. Perhaps there have been endless versions of ourselves who have lived, loved, lost, and looked up at the sky asking the same question. If the universe breathes, then consciousness too is a breath within that breath appearing, vanishing, then appearing again in the next inhalation. However, not all scientists agree with this vision. Many argue that entropy, the natural tendency of disorder to increase, would make each cycle progressively more chaotic, preventing a return to any pristine state. Yet, it is precisely here that new theories arise. Some quantum models suggest that the universe possesses a self-renewing mechanism, like a spring recovering its energy after each compression. Quantum fluctuations during the contraction phase could erase the imprints of chaos, allowing the universe to revive in order once more. If that is true, the universe not only endures forever, but preserves its youth through endless rebirths. Looking deeper, this cyclic idea carries not only physical implications, but philosophical depth. It tells us that nothing is ever truly lost. The endings are merely transformations of form, not destructions of essence. Just as water evaporates, becomes cloud, falls as rain, and returns to the sea, the cycle is neither beginning nor end, only continuous metamorphosis. The universe, in that sense, is also an infinite loop of renewal, where all things are reborn in new forms, each time subtler, more complex, more meaningful. And if we accept that the universe breathes, then perhaps we, tiny beings on this small planet, are part of that same breath. Every thought, every fleeting moment of existence is a small note in the cosmic rhythm. When we look up at the sky, the light of distant stars is telling the story of the universe's previous breaths, its expansions and contractions, whose echoes we only just begin to perceive across the corridors of time. The cyclic model is not just a hypothesis of physics, but a reminder the universe is not a tale told once and finished, but an eternal symphony still being played. In that symphony, each cycle is a chapter, each chapter rewriting the same questions in a new language. And though we live for only a moment within one cycle, our consciousness remains inseparable from that eternal breath. When we grasp this, the fear of nothingness dissolves. For if the universe can return, if everything can be reborn, then nothing truly disappears. The light that fades today may be the first spark of tomorrow. The end of one universe may be the first breath of another. And if we listen deeply enough amidst the echoes of space, we may feel that heartbeat. The heartbeat of the cosmos still pulsing, still breathing as it has since the beginning, and as it will forevermore. In ordinary understanding, nothing means absolute absence. No matter, no energy, no light, no sound, only an infinite void. But as modern physics shines deeper light upon this seemingly obvious concept, a revelation unfolds. The vacuum is not empty. Beneath the calm surface of nothingness lies a sea of restless energy, where virtual particles are constantly born and annihilated, where space itself, apparently silent, is in fact a living web of potential. Nothing, it turns out, is the very foundation of everything. In quantum mechanics, the vacuum is not defined as utter emptiness, but as the lowest possible energy state. Even there, quantum fields, the invisible background waves of the universe, vibrate ceaselessly. These fluctuations are not measurement errors, they are the nature of reality itself. Even if all matter were to vanish, the energy of the vacuum would remain like the faint breath of the cosmos itself. From it, pairs of particles and antiparticles appear for fleeting instants, then annihilate each other, leaving behind ripples of quantum vibration that never end. Through quantum eyes, the universe is not built from matter, but from fundamental energy fields where matter is only a temporary expression. What we call an object is really a stable region of oscillation within the field, like the crest of a wave on the surface of the sea. That sea of energy is the vacuum, the matrix that gives birth to all things from the tiniest electron to the largest galaxy. Everything that exists originates from it, and in the end dissolves back into it. The universe in its deepest sense is not built upon the foundation of something, but upon the foundation of nothing. A kind of nothing overflowing with energy, possibility, and latent creation. The wonder is that the vitality of the vacuum can be proven experimentally. The Casimir effect is one example. When two metal plates are placed parallel to each other at an extremely small distance, they are pulled together not by any conventional physical force, but because the vacuum energy between them is lower than the energy outside. In that experiment, the vacuum behaves as though it possesses pressure, a compression born from the countless virtual particles vibrating around it. An empty space, it seems, can push and pull on matter. Nothing suddenly becomes something immensely powerful. From this very sea of energy, the universe itself may have been born. The idea of a universe from the vacuum is no longer philosophy, but a serious direction in modern physics. If the vacuum is filled with oscillating energy, then a sufficiently large quantum fluctuation could make it pop into a bubble of concentrated energy, a tiny universe. And if the conditions were right, that bubble would expand to become the cosmos we live in. In other words, the universe was not created from absolute nothingness, but from a nothingness filled with potential, a creative vacuum. Through this lens, the concept of nothing becomes far more profound. What we call nothing is not absence, but the hidden essence of something. In Eastern philosophy, this has long been described through the concept of void. Not a negative emptiness, but the source from which all things arise. Now science says the same, but in the language of mathematics and energy, nothing does not exist because even nothing is a form of something. Thus the boundary between existence and non-existence grows faint. Perhaps the universe was not created from outside, but unfolded from its own underlying energy. A tiny fluctuation in the vacuum, what we once called chance, may have triggered expansion, giving rise to space, time, and the laws of physics themselves. In that instant, nothing became something. And from that paradox, everything began. If we pause to reflect, we see that this is not only a physical description, but also a metaphor for the nature of existence itself. In life, creation often begins from emptiness, from stillness, from silence before the sound, from darkness before the light. Perhaps the universe too is a vast symphony, and the vacuum is its opening rest, the silent note from which all melodies wait to be born. Physicists sometimes suggest that the energy of the vacuum could be the source of dark energy, the mysterious force pushing the universe to expand faster than ever. If that is true, then what drives galaxies apart is not matter, but the energy of empty space. That nothing is expanding the cosmos, shaping the destiny of everything. Within every cubic meter of space, though seemingly void, lies an immense amount of energy far beyond imagination. And when we understand this, we begin to see that nothing is an illusion. The deeper we look into emptiness, the more alive it becomes. The deeper we listen into silence, the more clearly we hear the hum of energy. Every photon, every vibration, every ray of radiation is an expression of an active vacuum, like the sea rippling even without wind. Space does not stand still. It trembles by its very nature. And within that trembling, everything that exists continues to arise. When we gaze into the night sky thinking we are looking into the emptiness between stars, we are in fact seeing the very field of energy that gave birth to all things. That shimmering light, that vast distance, all rest upon the fabric of the vacuum. And even as the universe ages and cools, that fabric remains still vibrating, still carrying within it the potential to create endless new worlds. Perhaps this is the greatest wonder of all. The universe was not born in the vacuum, but from it. Empty space is the source, not the consequence. And if we look deeply enough, we can perceive a beautiful paradox, that everything, including ourselves, is a temporary expression of an infinite vacuum, a nothingness brimming with energy, dreaming itself into form. So when we say, there is nothing, perhaps we are wrong, for nothing has never truly been nothing. It is everything waiting to be revealed. It is the foundation of reality, the birthplace of light, the silence before the song of the cosmos. And within every breath of space, within the vibrations of emptiness itself, the universe continues to create itself as though nothing is the way the universe keeps its power to become everything. From the very first moment the universe awakened, something paradoxical yet undeniable occurred. It began to swell. Space, instead of being a static stage, started to expand on its own. In less than a fraction of a second, it grew by a factor of trillions upon trillions, a sudden eruption that physicists call cosmic inflation. But the strange thing is, according to what we understand about quantum physics, that inflation may never have stopped. One region of space could end its expansion to form a universe like ours, while other regions keep swelling. And within that vast ocean of space, new cosmic bubbles continually emerge, each becoming a distinct universe with its own laws, its own constants, and even forms of existence beyond human imagination. This is the idea of the bubble universe, or what is known as the inflationary multiverse. According to it, the universe we inhabit is merely one bubble in an infinite ocean of expansion. Like bubbles forming in boiling water, these cosmic bubbles arise when the inflation field, a kind of false vacuum energy, is disturbed by quantum fluctuations, causing a small region to fall into a lower energy state. When that happens, the excess energy is released, transforming into matter and radiation, initiating a new universe. Each bubble is a localized Big Bang, a self-contained realm of space and time. The extraordinary part is that this process could go on forever. When one region of space ends inflation, others continue to expand faster than the speed of light. This means the total space will never stop growing, and new bubbles will endlessly appear within it. Each bubble is a separate chapter in the infinite book of reality, never repeating, never ending. If this is true, then the universe we observe with its hundreds of billions of galaxies and countless stars is but a grain of sand in a boundless desert. Each other bubble may possess completely different physical laws. In one, the speed of light might differ. In another, gravity may be stronger or weaker. In another still, the proton may be unstable and no atoms ever form. Some universes may exist only for an instant before vanishing, while others may last for trillions of years, nurturing life, consciousness, and questions about their own origins, just as our universe is doing now. In this picture, the idea of a unique universe shatters. There is no longer one universe, but countless ones. No single beginning, but an endless chain of beginnings. And if we exist within one bubble, then everything we know, physics, space, time, is true only within the confines of that bubble. Beyond it, where inflation still rages on, the physics could be so alien that our language cannot even describe it. What makes this idea so captivating is not only its strangeness, but that it arises naturally from mathematics. The equations of inflation do not merely allow but require the creation of new bubbles. They need no external cause. They arise as an inevitable consequence of quantum energy. With every fluctuation, a new region drops out of inflation, spawning new space. In that sense, the multiverse is not a fanciful hypothesis, but a logical outcome of expansion itself. Thus, the question, where did the universe begin, loses its meaning. For in an eternally inflating ocean of universes, there is no absolute beginning, only infinite local ones. Our universe is simply a bubble that reached equilibrium while outside it creation continues unceasing, boundless, and without purpose beyond existence itself. Yet this idea also carries a profound sense of awe. If there are infinite universes, then every possibility occurs somewhere. There might be a universe where human history never began, a universe where Earth never existed, or even one where another version of you is looking up at the sky asking the same question. On an infinite scale, everything that can happen will happen not once, but infinitely many times. And at that point, the boundary between probability and reality dissolves. The bubble universe is not just a physical model. It is a philosophical mirror reflecting the question, what gives our existence its uniqueness? The astonishing thing is that even though these bubbles cannot communicate with one another, they might leave traces. When two bubble universes form close together, they can collide. The impact between two spaces could create subtle distortions in the cosmic microwave background. Faint circular imprints that astronomers are still searching for in the sky, ancient light. If such a signature were ever found, it would be the first evidence that our universe is not alone. But even without direct observation, the idea itself carries breathtaking beauty. It shows that the universe is not a random accident, but the natural consequence of laws that allow all possibilities to manifest. Each bubble is an experiment of nature testing different versions of reality. And we, in one small corner of one small bubble, are aware of the entire process, a sign that consciousness can arise even from pure chance. Perhaps what makes this model so profound is not that it expands the scale of the universe, but that it expands the meaning of reality. If infinite universes exist, then the boundary between real and unreal, between being and non-being, becomes a matter of perspective. Our reality is not absolute. It is one thread in a vast network of infinite potential. And if that is so, the question is no longer, why does this universe exist? But why are we in this universe? A question that transcends physics and touches the essence of consciousness and presence itself. Seen this way, the idea of the bubble universe does not make existence meaningless. It makes it sacred. For in an infinite reality, our being here now becomes a miraculous coincidence, a rare harmony between numbers and meaning. And perhaps in another bubble, another version of us is saying the same words, looking at the same sky, wondering if their universe is the only one. In the final breath of reflection, the notion of countless parallel worlds ceases to be frightening. It becomes the song of eternity where everything that could ever happen is happening and will always continue to happen. The universe, instead of being a single explosion in the dark, is a rainfall of universes, each droplet carrying its own story, its own laws, its own soul. And within that boundless ocean, we, a small being within a bubble of light, are learning to recognize that our very existence is part of this infinite dance, where the random and the inevitable merge as one in the rhythmic breath of the multiverse. Perhaps the Big Bang was not the beginning of everything, but merely a collision in a higher dimensional space between parallel universes drifting through the metaphysical ocean of existence. In this vision, The Big Bang was not an explosion out of nothingness, but a touch, an intersection between two cosmic membranes where the energy of higher dimensions compressed to the point of detonation, giving rise to time, space, and the entire story we are living within. This theory was born from the effort to unify general relativity and quantum mechanics, a journey in physics to find a common language for two realms, the infinitely large and the infinitely small. When scientists extended the mathematics of string theory, they discovered that the equations only truly fit when more spatial dimensions were added beyond the familiar three. In those models, the universe is not merely a three-dimensional space expanding outward, but a membrane, a brain, floating within a higher dimensional arena called the bulk. Each such membrane can contain an entire universe with its own time, physics, and reality. And when two membranes drift close enough, collision becomes inevitable. Imagine two immense ethereal membranes gliding through a multi-dimensional expanse. When they touch, their energies concentrate to a critical intensity, releasing a torrent of energy, what we perceive as the Big Bang. The time of Gaia universe began at that contact, but not the time of all things. For within the bulk, the flow of time could differ or even pre-exist before our universe came into being. This means that before the Big Bang, there might have been other dimensions already moving, colliding, and creating countless other Big Bangs. Each collision between two membranes can give birth to a new universe, like ripples spreading when two drops of water fall upon a lake. It is possible that even in this very moment, collisions are occurring elsewhere in higher dimensional space, generating other universes, each carrying its own version of reality. In this image, the Big Bang is no longer a singular event in history, but a recurring phenomenon within the architecture of higher existence, where universes drift, collide, and separate again like the heartbeat of eternity. The wonder is that this model is not mere imagination. It arises from the mathematics of M theory, an extension of string theory which suggests that all particles in the universe are not points, but vibrating strings or membranes within an 11-dimensional space. Within that framework, each membrane could be an entire universe, and there is no reason to assume that only one exists. The interactions between membranes through collision or oscillation could be the very origin of energy, of space, and of the cosmic expansion we now observe. If this is true, then the Big Bang was not the birth of space, but the transformation of higher dimensional geometry. Just as when two planes intersect in space, their intersection forms only a line while both planes continue to exist independently, our universe too may be the line of intersection between two broader dimensions of reality. And if we could somehow peer beyond the surface of our own membrane, we might see other dimensions, other universes drifting beside us, like ghostly reflections travelling parallel through time. Some physicists suggest that gravitational waves, the ripples in the fabric of space-time, could be messages from those other dimensions. If part of the collision's energy leaked through the membrane, it might leave subtle traces in the gravitational field we can detect. Every tremor in space could be the faint echo of distant collisions between universes, echoes still rippling across billions of years spanning distances beyond human comprehension. When one looks deeply into this model, a nearly metaphysical insight emerges. Our universe may be the product of an interaction, not solitary creation, but meeting. The collision of two membranes did not only release energy, it forged order, conditions so precisely tuned that life could emerge. Perhaps that is why our physical constants, from the mass of the electron to the strength of gravity, are calibrated with such uncanny perfection. They may not have been designed but shaped by the geometry of that original collision, by the angle, velocity and energy with which two worlds touched. And if every collision gives birth to a new universe, then each universe is a scar upon the body of eternity. No two are alike, yet all are woven from the same transcendent fabric. Existence in this sense is not a linear progression, but a vast web of encounters where dimensions cross, exchange energy, and part again in an endless cosmic dance. But if that is so, an inevitable question arises. Could our universe one day collide with another membrane again? If the first collision created the Big Bang, the next might ignite another, a new beginning for existence itself. Some models suggest that over trillions of years, As the universe expands, our membrane will stretch, oscillate, and gradually move toward another within the bulk. When they meet once more, a new cycle begins, and space, time, and energy are all renewed. This makes the Big Bang not a starting point, but a rhythm in an eternal symphony. Each collision is a movement in the cosmic play where light, matter, and consciousness flare into being only to fade and await their return in the next refrain. In that vision, there is no beginning and no end, only grand meetings between worlds where eternity gazes upon itself through infinite forms. And when we ponder this, perhaps we begin to understand why the universe possesses such beauty. Every star, every planet, every beam of light is the result of an ancient touch, a collision between two realities. We, the beings who question our own origin, may also be born from such a meeting of dimensions, creatures forged from the energy of contact. If so, our existence is not random, but a song that rises whenever two worlds meet, when light bursts forth and time begins to count its rhythm. When we listen deeply into the silence of the cosmos, we may sometimes sense that distant resonance, a faint ancient pulse, the lingering echo of that first touch. It still travels through space, across galaxies, flowing through time to remind us that the Big Bang was not the beginning, but a single moment within the infinite symphony of dimensions, where every collision is an invitation for the birth of a new world. Time, in human perception, feels like the most real of all experiences. It moves with the beating of the heart, with the ticking of the clock, with the changing colours of light across the sky. Yet when modern physics looks deeply into its nature, a strange truth appears. Time may not flow at all. It may not be a river streaming toward the future, but merely one dimension within the fabric of space-time, still and unchanging, where every moment, past, present, and future coexists. What we call the flow of time might only be a trick of consciousness, the brain's way of experiencing reality in a linear sequence. That idea sounds paradoxical, but it is an inevitable consequence of relativity. When Einstein wrote the equations describing the universe, he discovered that space and time cannot be separated. They merge into one, forming space-time, a four-dimensional entity. Within that framework, every event from the explosion of a star a billion years ago to the breath you're taking right now is a fixed point within the structure of the cosmos. Nothing truly vanishes or passes. If we could look from outside time, every moment would coexist like frozen frames in a completed film. It is only our consciousness sliding through the frames one by one that creates the sense of motion we call time. This leads to a new perspective. The past still exists and the future already is, though we have not yet arrived there. Everything that has ever happened, words spoken, glances exchanged, laughter, departures, has not truly disappeared. They remain embedded in the fabric of space-time like notes, etched forever onto the score of the universe. When we recall a memory, perhaps we are not merely imagining, but touching a real part of the universe where that moment is still unfolding. But if everything already exists, where does the sense of flow come from? Some physicists propose that it arises from entropy, the natural tendency of physical systems to move from order to disorder. As the universe expands, entropy increases and we perceive that as the forward direction. In other words, time does not actually flow. Only the change in the level of cosmic disorder makes us believe it does. We move from regions of lower entropy to higher entropy and call that direction the future. Going deeper, Stephen Hawking once suggested the concept of imaginary time, a kind of time that does not flow linearly, but has a geometry similar to space. In this model, the universe has neither beginning nor end, much like the surface of the Earth, round and continuous. If you travel far enough forward, you would return to your starting point without encountering any boundary called before the Big Bang. That means the universe could be finite yet without edges, and time, what we perceive as a flow, might actually be just another spatial dimension we are moving through. Imaginary time is not imaginary in the fictional sense, but a mathematical tool that allows us to describe what ordinary language cannot express. It lets us imagine the universe as a closed totality, where every point connects to every other. There is no absolute before or after, only the coexistence of innumerable states within a larger structure. Seen this way, the Big Bang was not the beginning of time, but a special point in the geometry of space-time like the North Pole, on a globe beyond which the concept of further north ceases to have meaning. This renders the very idea of a flow of time a limitation of human perception. Our brains evolved to survive in a three-dimensional world where causes lead to effects, where life requires a past to remember and a future to strive toward. But the universe is not bound by how we experience it. At its deepest level, every moment is merely a simultaneous slice of the same reality, and we, with memory and awareness, are moving through those slices like a point of light sliding along the film strip of eternity. And that opens a profound philosophical question. If time is an illusion, does free will still exist? If every moment, including our future choices, already exists within space-time, are we truly deciding or merely acting out a script already written? Some physicists argue that quantum unpredictability keeps the future open, but others contend that even randomness might be encoded within the structure of space-time itself. In either case, the unsettling and yet beautiful possibility is this: the universe may already be complete, and we're simply moving through it, reading the score of our own destiny. Yet, this does not diminish the meaning of existence. On the contrary, it makes each moment more sacred. If every point in time exists forever, then every second of our lives, however fleeting, is immortal within the structure of the cosmos. The laughter, the tears, the clasp of a hand, the light of a star streaking across the night, all are preserved eternally within space-time. Nothing truly disappears. We merely leave one moment behind to step into another. From this perspective, what we call the illusion of time is not a flaw of perception, but a gift. Because of it, we can feel the passage of life, remember, hope, and dream. Because of it, an unmoving universe becomes alive through human eyes. For if every moment already exists, then the present, this very instant, is the only point we can truly touch, feel, and comprehend. Perhaps in the eye of eternity, time does not move, but consciousness makes it flow. It is our minds sweeping across each slice of space-time that creates that flow, like a needle gliding across a record, turning stillness into motion, silence into melody. And within that symphony we realize that we are not merely listeners but part of the music itself, a single beat in the grand cosmic song. Thus, when we say time is passing, perhaps we should understand it differently. It is not time that passes, but we who move through it, travelling across the unmoving dimensions of reality. And though the past and future may already exist, there is still something miraculous unfolding right now in the moment when consciousness becomes aware of being alive. For it is in that very moment that imaginary time and the illusion of time's flow merge into one, and we, adrift in the imagined current of eternity, suddenly realize that we are the witnesses of the universe, dreaming its own dream of time. Could it be that everything we see, the sky, the stars, the flow of time, emotions, and even consciousness itself, is not real in the material sense, but merely a sophisticated simulation, a vast construct of information where energy, particles, and space are simply manifestations of data? This question once belonged to philosophy, but now physics and technology are bringing it back as a serious possibility. The universe may be a program running on the very substrate of reality itself. This idea is not new. It was first planted in ancient philosophy when Plato spoke of humankind living in a cave of illusions, seeing only the shadows of truth projected on the wall. But in the age of quantum theory and computation, that image takes on a new meaning. If every particle of matter can be perfectly described by equations, if every physical law operates through logical rules, then isn't the universe functioning like an immense computational system? In quantum mechanics, a particle does not exist in a definite position until it is observed. It exists only as a set of probabilities. Much like a stream of data that has not yet been rendered on a computer screen, when an observer appears, the system updates its value as if processing an image only when needed to conserve energy. If we accept that reality operates this way, then the simulation hypothesis ceases to be fiction and becomes a coherent description of how information may operate to generate existence itself. Some physicists, such as Nick Bostrom, have proposed a now famous argument. If a civilization could ever reach the level of creating perfect simulations of reality, then the probability that we are living in one of those simulations is infinitely higher than the probability that we exist in the original world. For if technology can recreate universes, there would be millions of copies, each containing billions of beings convinced they are living in the real one. The cold statistics suggest that the chance of us inhabiting the base reality is nearly zero. Yet this question is not merely an intellectual game, it cuts to the very roots of the philosophy of being. If reality is a simulation, then who is the programmer and what is the purpose of the game? Perhaps the universe was not born from randomness, but from an intelligence not necessarily divine, but capable of constructing an environment in which consciousness could learn about itself. Maybe every physical law, every constant, every coincidence that appears accidental has been fine-tuned like lines of code designed to create the conditions for life, awareness, and self-reflection. From that perspective, we are not meaningless organisms drifting through a cosmic sea, but participants in a self-aware program in which the universe experiments with the act of knowing itself. The programmer may not be outside at all. It may be the universal consciousness of the cosmos, dividing itself into countless fragments to experience every facet of existence. Like a dream dreaming itself, the universe simulates in order to know what it is. What is astonishing is that quantum physics increasingly supports this vision. Experiments in quantum entanglement show that all particles in the universe can remain instantly connected even across billions of light years. This mirrors a computational system in which all information is processed simultaneously independent of physical distance. The universe appears less like a three-dimensional space and more like a unified data network where every point knows about every other reality when seen through the lens of information. It ceases to be matter and becomes code. Physicist John Wheeler once said, "It from bit. Everything that exists arises from binary information, from bits." At the most fundamental level, the universe may be described through the simplest choices, yes or no, 1 or 0. Everything from photons to galaxies is merely a complex pattern of information interpreted by consciousness. When we look at the sky, we are not seeing matter, but the result of a vast process of data rendering where light is the signal and we are the interpreters. If that is true, then the frontier of science no longer lies in finding the smallest particle, but in uncovering the computational foundation of reality, the equivalent of the universe's processing engine. One day, we might detect the resolution of space itself, a threshold below which continuity breaks down into discrete units, like pixels in a digital image. And if we ever discover these atoms of space, the minimal units of information, we would hold proof that the universe is not a flow of matter, but a program, a data structure. But this in turn opens an even greater, almost metaphysical question. If the universe is a simulation, where is the base reality? And do the programmers of that higher world realize they too might exist within yet another simulation? Thus, the chain of questions could stretch infinitely like mirrors reflecting mirrors, leading to the strange conclusion that every layer of reality could itself be simulated, and that real is only a matter of perspective. At some level, though, that may no longer matter because whether simulated or not, consciousness is still experiencing emotion, love, pain, and joy. Whether generated by lines of code or neurons, they're real in experience. Reality is no longer defined by matter but by perception, and that turns the question, are we real, into its inverse? If we are not real, why does it feel so? In this light, perhaps the goal is not to discover whether we live in a simulation, but to understand the meaning of being within one. If the universe is a program, then each human being is a line of self-writing code experimenting with the possibilities of awareness, and if everything is designed for learning, then consciousness, not matter, is the true center of reality. When we grasp that, we realize the universe does not need to be real to be meaningful. It only needs to be experienced. For within every layer of simulation, there remains one element that transcends all, the sense of presence. The awareness of I exist cannot be simulated, for it is the foundation upon which everything else arises. Perhaps that is the ultimate secret, that this entire simulation, from the Big Bang to the night sky, is the universe's way of knowing itself through our consciousness. Reality may be a simulation, the universe may be a program, but within that code, amid numbers and probabilities, there exists something undefinable, a spark of awareness that turns information into experience, data into life. And perhaps when we finally ask the ultimate question, am I real? It is the universe itself answering through us.